First of all, I would like to refer to definition of this product. What is the extra virgin olive oil? This is an oil obtained only by physical processing and operating at reduced temperature, so that this product was characterized by excellent sensory properties and low free acidity. But the reason of its success depends not only on its nutritional and chemical composition, but even by the benefits who come from its daily intake. In this slide, I report only some reference among many papers that are present in literature and speak about the great health benefits who derive from extra virgin olive oil consumption. But one of the problems of extra virgin olive oil production is the low efficiency of the extraction technique, because the extraction technique have remained unchanged over the last 20 years. So what was our idea? Because I and my group of research work even in enology, and know that the addition of solid carbon dioxide allow to produce high-quality wines, very strongly linked to its area of production, we decided to apply this technology to extra virgin olive oil extraction. The method of extraction was patented and involved the addition of a cryogen, for example, solid CO2, to the olives. The aims are to increase the extraction yield and obtain an oil characterized by a higher concentration of its health compound, such as phenols and tocopherols, and a stronger link with its production area. Among all the cryogen suitable for food technology, we started in this experimental run, we used solid CO2 because of its advantages. CO2 isn't toxic, is not inflammable, is a good solvent, and so on. And at last, but not the least, this compound is an enzyme inhibitor. For example, is an inhibitor of lipoxidase. Okay? The characteristic of CO2 is that at atmospheric pressure pass directly from solid state to gaseous state according to its temperature, okay, to operating temperature. During the sublimation, carbon dioxide take away a lot of heat, so the temperature of olives reduce greatly. As a consequence of addition of solid CO2, there is a partial freezing of endocellular water. Because of ice volume is greater than water volume, there is a cellular crash, collapse the endocellular system of membranes and cell wall collapse. And this make easier the diffusion of cellular components in the extracellular liquid phase. Moreover, the density of CO2 is greater than the density of air. In this way, it was formed an inert gaseous layer which protects from oxidation the extracted oil. In this way, it's possible to increase the extraction yield to have a higher antioxidant content, because the antioxidant content of a product is the result between the compounds extracted and the compounds transformed, for example, by oxidation. Okay? Another great advantage is the aromatic profile, because aromatic compounds aren't oxidated. What was done until now? They were determined the values for the main parameters, because no reference are available to use for the extraction of oil with the new method. It was verified the influence of cryogen addiction to the olives in the first phase of the experimentation during pre-milling phase. In this slide, it was presented our research group, and in this photo, it's possible to see even my colleague Francesca Venturi, which at this moment is a chair. Even our university is older, but we hope, because it's a university of 1,343. The micro oil mill used in these experimental runs is a commercial micro oil mill called Olio Mio Baby, that was suitably modified for the addition of solid CO2. In experimental run, an amount of 20-30 kilograms of olives were poured inside the receiving hopper, and then by a screw, the olive arrived to a knife crusher, so the olives were transformed in olive paste. After the crushing, they fall down in an horizontal continuous malaxer, and after malaxation, a two-phase decanter allows to split oil from wet olive residues. The olives used in this experimental activity come from Tuscany. That is a region in the center of Italy, and are harvested in 2 different years. The olive used in each experimental run were 60 kilograms and were mixed to have homogeneous fields, so that each sample was split into fractions. One fraction is used in traditional extraction process. The other fraction was added by solid CO2. In this slide, we can see the characteristic of the olives, because they were collected in 2 years, very different each other. In 2010 is a very good year for olives production. But 2014 is the black year for olive production, because the weather isn't fine, and the olive are few and damaged by the fly. In this slide are presented the main operating variables adopted during the experimental runs. When the amount of olives are sufficient, we have used a different amount of cryogen, with the ratio of 0.1, 0.15, and 0.2 to verify if the amount of cryogen could influence the results of the extraction. It's useful to underline that the water added during the process to make easier the separation of water from oil is less with our system than with traditional one. In order to evaluate the effect induced by the addition of the cryogen on the oil extraction, it was introduced a parameter, the extractability index variation, which is a combination of two different parameters. EC, that was the oil extracted, the ratio between oil extracted and the oil present in the olives, okay, at the origin, because not all the oil is extracted with the normal process. And ET, that is the oil extracted in relation to oil present in the olives with the traditional method. In this slide, we present the result obtained as regard as the oil extraction yield. We can see that the direct addition of cryogen to the olives during the permilling phase could induce a general increase in the oil extraction yield, even if there is a certain variability among the results. What about the oil extraction yield? There is another feature that is important in this method, because working in 2014, we realized that this method allows to harvest olives earlier, so to reduce greatly the damage due to the third fly attack of Batrachera oleae, that is the Latin name of olive fly, that can induce a loss in oil production up to 60% and a great decrease in oil quality. As regard as the quality of oil, we used two markers, the tocopherols content and the total phenols content. The percentage increase in tocopherols content remain quite constant, around about 6%. But even there is an average increase in total phenols, the problem is that the results have a great variability. And this variability is not easy to explain. As concerns the oil general chemical parameters, which are present in European regulation, there aren't a reliable difference due to new extraction method. Probably this evidence is due to the high efficiency of the extraction plant. And in this slide, there are present all the analysis regarding the free fatty acid content, peroxide value, and the absorbance at the characteristic wavelength. We can say that the parameters are always lower than the maximum prescribed by EC regulation, even during the terrible year of 2014. In conclusion, in the first part of our experimentation, what we can see. The general analytical parameters don't show reliable differences due to new extraction process. And this proved the efficiency of a micro-oil mill used. The concentration of phenols tends to increase, but is a great variability. And this variability don't seem to be related to the amount of the water remaining in the oil, because we know that the phenols are more soluble in water than in oil, as a function of its degree of polymerization. The concentration of tocopherols increase using the new extraction method, increase in each run, in each experimental run. The CO2 solid addition seems to increase the extraction yield, and this effect is greater when the olive water content is greater. So we have, and even when an higher ratio between solid carbon dioxide added on olives squeezed is used. The possibility of using olives early harvested could limit the losses due to Batrachera oleae, and this can be very useful in difficult year of production. And so after this first year of experimental runs, we can say that new extraction method could allow to obtain an extra virgin olive oil with a higher concentration in bioactive compounds. And this can increase its nutritional properties and its antioxidant activity, and as a consequence, its shelf life. What will be done in the next future, we hope? We would like to control the changes in chemical and sensory qualities, both for oil extracted with a new system and the traditional one, as a function of storage time. Because we would like to follow the oil during storage, okay? And this is for us an important possibility. And we would like to set up a more complex, innovative plant because our micro plant is not able for improvement, for modification, for further modification of the extraction process. In particular, we would verify if the cryogen addition can be done even or during the malaxation. I would say that this project was selected for the presentation at Expo in Milan the next 24 August at Italian Pavilion, and this could be an help for us to fund the research, financial support for this research. This reference in this slide were reported some papers related to the last papers written by our group about this field. I would like to thank the research group of Professor Fabio Favati and Susanna Fartolini for their help, and Sarah Rigoni Farm, that is a farm near La Spezia that took part in the experimental activity and give us a good support. I hope to see you in Milan to Expo, and thanks for the attention.
Thank you, Professor Zinnai, for this presentation. Any questions?
Thank you for the presentation. I have just a pair of questions on the research. So the first one is that, is it economically feasible, and is there any real advantage of using CO2 in olive process? Because from 100 kilos of olives, you can obtain very few liters of olive oil. And I saw that the yield improvement is very little. So is there any really advantage in terms of economic at industrial plants?
Yes, but we use a micro-oil mill, so this, and the cost of carbon dioxide is very low. We do a prevision of cost, and even in this condition, the costs are covered. Perhaps I have a slide about this provisional cost. I don't know if the slide is in Italian. Okay. Okay. This is the slide about the provisional cost. Even in this condition, there are there is an advantage. But the real advantage is even in quality, not only in the extraction yield. And even we would like to have more possibility, because in this condition, with our micro-oil mill, we can do the addition only in the pre-milling phase. But the real good opportunity is using during malaxation. But in this micro-oil mill, this isn't impossible. And another opportunity is to extend the process until the bottling phase, because we wouldn't we would like to maintain the characteristic of our oil for more than 1 year. And this is a good opportunity because CO2 is a polar and it can dissolve inside the oil and have a density greater than air. So even during the bottling phase, this effect could remain. Naturally, these are only preliminary results because we are waiting. We are constituting an operative group that in Italy is a group of research to have a plant, a greater plant, to do to develop the following aspects of this method. But now this is the only results.
And also, my second question was about phenolic compounds. Of course, this improves the amount of phenolic compounds, but there are some varieties where phenolic compounds are higher than expected, and also phenolic compounds implies bitterness, so consumers do not accept so very well the bitterness and pungency of olive oil. So there are industries which try to below it.
I not agree with this. I don't agree with this phrase because the bitterness of phenols depends on the degree of polymerization. Okay. And when the degree of polymerization is higher, the solubility of phenols inside the olives is greater. And the taste is a good taste, okay? Only simple phenols are bitter, okay? As a demonstration of this fact, in Italy we are different oil. Oil bitter, but even oil soft, sweet, very sweet. From two different sides of a hill, for example, because there is a great influence of UV radiation on the degree of polymerization of phenols. Even the degree of ripen could be very useful for this aspect, because when the ripen go on, the degree of polymerization is reduced in olives. So we can select the best date for harvesting. Okay? So we can reduce the loss of phenols inside the water. The water, and we have two beneficial effects. To reduce the pollution of water coming from olive meal, and to have a higher content of phenols inside the oil. But all these aspects, we are waiting to develop these aspects.
So you characterize the wastewater from both treatments, and you find that in the wastewater treated by CO2, the phenolic compounds were lower.
Yes, but our problem in this moment, and in some, the average content of the water, because we do a mass balance considering even the water, okay? Because after the separation, we wash accurately the two-phase extractor, okay? And do the mass balance of all phenols content, okay? Considering the phenols contained in residues, the phenols contained in water, and the original content in olives. The difference between all these values must be the phenols content in oil. And in some cases there are differences, and sincerely we couldn't understand why there is this difference. The average content is higher, okay? But in some situation, in 2 or 3 of 8 experimental runs, it's lower. And we think that it can depend by the fact that the olives in 2014 are greatly damaged by the Bactrochera olee. So there are the phenol's content is affected by the quality of raw material in this case. Okay?
Thank you. One last question.
One of my comments from analytical chemistry and from plant physiology points of view, you can say that a new extraction increased the content of phenolic compounds in raw material. You have to say that the yield of extraction using new method increased. Or you can say that the content of phenolics obtained using new extraction was higher than that of something else, because extraction doesn't change. That doesn't change really metabolism of your samples during the process. But this is typical error used. Almost everyone is using, but really it's not true.
Not inside the olives, inside the extracted oil.
Now what you told that the content of phenolics in this increase, it's not true.
In the oil.
It's a different
Point of view.
It's a different composition of the oil, and the extraction methods can influence the oil extracted. Absolutely, yes.
But it means
But
something has happened in the oil. But it's the transfer from material to the oil during different physical chemical properties of the process. But
I thought so. We are sure because we do the mass balance of each fraction, and so we consider the total amounts respect of the initial content of raw material. Not only we consider the content, the oil content of this fraction, but we do a general mass balance, and the mass balance closed. Okay, the quantity we found in oil, in water, and in residual, in olive residue, in waste, are the same. From a statistical point of view, are quite the same. So, greatly influence. Greatly influence. For example, the quantity of water used in the extraction influence greatly the phenolic content. So it's very important to use and reduce the quantity of water, because polyphenols are more soluble in water than in oil, or at least a fraction of phenols. The phenols with a low degree of polymerization. This is no.
One simple question. My question is related to the tocopherols.
Yes.
You indicated that after extraction, tocopherol increased,
Yes.
which is important for the public health. As we know, we have 4 isomers of tocopherol, alpha, beta, gamma, and sigma. And I would like to know which isomer was increased or all, because alpha tocopherol is generally accepted from the public because the alpha protein binding, etc. However, gamma, beta, and sigma is discreted from the human body to the different metabolites. So from the point of view of the storage oil, it would be okay if we be quite enough, for example, sigma tocopherol, because the antioxidant activity is higher than gamma, sigma, and alpha.
Yes.
But from the human health, alpha is the most important. What was the profile of
Yes,
tocopherols?
yes, but the tocopherols analysis are carried out by the group of Professor Favati. So in the paper I reported the single fraction concentration in the last paper, of the greater value, we use only the data related to total tocopherols amounts in this paper. In the following paper, you present the different fraction of tocopherols. But the real difference is not is to reduce, is the great advantage is to reduce the loss inside the waste. Because, for example, after extraction, the olive waste remain of color of a violet, of a purple color, not became brown, such it normally occur during the traditional extraction process. And this is really interesting. Even another important factor is the effect of CO2 is similar to when we put a bottle full of water inside the fridge. Okay? The bottle was broken, and because a lot of compounds are contained inside the vacuums, and the cellular membrane break is favorable to the extraction. Okay? To the extraction in the oil phase, because in the great majority of the extraction, the problem is to make easier the diffusion inside the oil phase. And so a lot of noble compounds remain in the waste. And this is a pity for two motives, because of the pollution and because we have a product with less concentration of these compounds.
Thank you. Any question?